I'd like to thank the organizers for the opportunity to join you all today, and hopefully I can share some of the experiences that we're going through in Iowa and the upper Midwest and how that complements the efforts that are going on here. The previous maps have shown that it's all hands on deck. There's all sorts of parts of the country that have roles and responsibilities. It'll all be a little different depending upon where you live in the country. And so some of my story may not be an exact match to the story in Texas and Oklahoma, but hopefully some frameworks or some perspectives can be helpful. I'd like to thank the Iowa Monarch Conservation Consortium, which formed during the spring and summer of 2014, and they've been helping to support in part some of the research I'll be describing. The consortium is a group of over 35 organizations that represent Iowa Department of Agriculture and Department of Natural Resources, the university, of course, but also the major commodity and livestock organizations in the state, as well as conservation organizations, utilities, pesticide technology providers, and ex officio representation from USDA, U.S. Fish and Wildlife Service. So this consortium brings together quite a diversity of stakeholders, all with a common vision of trying to see what we can do through voluntary efforts to support monarch conservation, not only in Iowa, but in neighboring states, and again, coordinating with our federal partners. Our goal is to try to move forward and design conservation practices that are effective. They work, but they provide flexibility for the private landowner. As our previous speakers alluded to, essentially all the land that's going to be in play for monarch conservation is owned by private landowners. And at least in Iowa, way over the top in terms of the majority of that land is owned by farmers and livestock producers. So that's where the action is going to be, to create the number of acres that are going to be in conservation. So our goal is how to develop a robust strategy that's a win-win-win. It's the win for the monarch, because we're conserving the monarch. It's a win for landowners, primarily associated with agriculture, to have flexibility in the techniques they're going to use to help support that conservation. And frankly, it's a win for U.S. Fish and Wildlife Service, because they don't want to list this species. It'll be the end of the service. So the consortium guiding principles you can see on this slide, and I want to highlight is the phrases in bold, which get back to the agricultural sector. Not that these concepts don't apply to everybody, but we want to have practical approaches, and we want to make sure they work. We want to focus on underutilized areas in rural landscapes. We're not asking farmers to start growing milkweed between their soybean and corn rows, but what about the underutilized areas on their farms? What about unproductive areas in their farms? But we have to figure out how we're going to do monarch conservation and avoid conflict with egg production. And this it has to happen on a scale that's sort of mind-boggling in terms of improving the breeding success. But it's doable. So some of the research that we're doing at Iowa State and with other partners is in part taking a look at the techniques for establishing and maintaining monarch habitat. We heard previous discussions around seed mix and the quality of seed mix. What's the right kind of seed mix in different parts of Iowa? How do you prepare the site? What are the input costs so that we can help NRCS and FSA better understand what those input costs over especially the first 3 to 5 years of establishing these sites. Also research that you could loosely call about designing habitat. Better understanding of the larval and adult needs for different milkweed species and forage plants. Landscape scale studies trying to understand how patchiness of habitat in the landscape influences egg density and then adult recruitment, and then the effects of insecticides and herbicide use as we think about the design. With regard to the first area that I mentioned, we have habitat restoration projects going on in not all over the state, but in sort of key parts of the state. Some of them are funded by the Iowa Pork Producers Association. One project's funded by the Iowa Soybean Association, and then 2 from NRCS. 2 of these projects are trying to see what are some options in linking water quality management with monarch conservation. So as we're installing bioreactors and establishing saturated buffers to reduce nitrogen and phosphorus loading, can we put milkweed habitat, monarch habitat, on top of that ground cover? Also taking a look at putting in monarch habitat in swine production facilities. There's lots of Kentucky bluegrass there that could turn into some other plants and milkweed. And then with the National NRCS grant, looking at underutilized areas on farms, grass-dominated landscapes, brome fields, for example, it could be converted. So when you take a look at that map, you can imagine that there's going to be a patchy quilt work of habitat across the state. And so Tyler Grant, a postdoc in our group, has developed an agent-based model to look at spatially explicit landscapes in Iowa, but it could be applied in other areas. And what this model does is it models the individual behavior of female monarchs. You can model up to 250,000 monarchs in the state, 25,000, say, in Story County, Iowa, and we can take a look at how these monarchs are going to move across the landscape and where they're going to lay their eggs in the landscape. And now we can do some what-ifs about putting habitat patches in different places and make some estimates about how much egg density we'll get. It makes a difference where those patches go, which then gets us into crop production. So we got a lot of corn and soybean. You all got cotton and soybeans too in different parts of the South. And so we need to be able to grow these crops and grow monarchs at the same time, and we think we can. But it's important to look through some of the trade-offs, some of the conservation risks and benefits that may be in play. EPA is clearly concerned about monarch conservation and habitat use, and they put out for public comment some options on herbicide use. Maybe herbicides shouldn't be used within certain distance of patches and other options that they're interested in public comment. NRCS last year had guidance that discouraged establishment of habitat within 125 feet of a crop field that's using insecticides or herbicides. When we take a look at Story County, Iowa, and you put a 125-foot buffer around all the corn and soybean acres in the state, over 80% of the rural roadside habitat would be off limits for habitat restoration, and nearly 40% of the non-crop land would also be ineligible for habitat restoration. If you pull that out of the model, you produce a lot less eggs. So what's the scientific basis for using that buffer? And that's some of the research we're trying to do. What are the conservation trade-offs if we move habitat close to the fields or we keep the habitat away from the fields? And what's important to remember is the monarch's a vagile species. It moves around a lot. It doesn't put all its eggs in one basket. It spreads its eggs across the landscape. So what we want to do is take a look at the risk of representative pesticides at the individual level, get those dose response curves, if you will. How much of exposure to a herbicide influences the milkweed? How much of an exposure of an insecticide to a monarch causes effects? And then we can put those dose response relationships into Tyler's model and take a look at what happens at the landscape. So we can predict risk at the patch scale. We can predict risk at the landscape scale. The previous speaker talked about the importance of keeping track of when your crops are growing, when your pest pressure may occur, when pesticides may be applied, and how does that relate to when the monarchs are going to be in the landscape. So in Iowa, we have corn planting that goes on from early, and soybean planting that goes from early April to mid-May. And if they're using neonic-treated seeds, that's when there could be some downslope movement of the neonic and potentially some uptake into the milkweed plants. Recently, a lot of farmers have been putting in rye cover crop for part of their nutrient management. That's causing fall armyworm infestation sometimes in the spring. So now there's some foliar applications that are occurring in the spring when the first generation of larvae in Iowa are starting to become abundant. In the late season in soybeans, we can have soybean aphid outbreaks. That can happen between mid-August to mid-September, and that's when the last generation of larvae are in the state. So we've got windows of time where farmers may be dealing with economically significant pest pressure, and they may also have monarch habitat near their fields. So how could the monarch, or the milkweed or the monarch, get exposed? There could be aerial applications, in this case to a soybean field, and you could have movement downwind due to spray drift into habitat that could be next to the field. So you could have pesticide deposition on the milkweed or the forbs, or on the insecticide on the monarchs. So that's one exposure route. Another exposure route, which is potentially important in Iowa, has to do with neonic-treated seeds. So neonic insecticides are wrapped around the seeds to help protect the plant just after germination. Those are systemic insecticides that move up into a plant. So if they're milkweed downslope of these fields, the product could move subsurface and get taken up in the milkweed and then become an exposure route for the larvae. So Bob Hartzler and Sidney Paul, a MS student with Bob, are taking a look at some of the issues with regard to herbicide exposure. They're using a number of representative herbicides to get a handle on how sublethal exposures change the growth and biomass of the milkweed. That in turn could be influencing how many stems does it take to produce the larvae, because maybe those stems don't die, but they don't provide as much biomass as an unexposed milkweed stem. They're also taking a look if damaged milkweed changes female oviposition preference, and again, taking a look at the biomass availability to the larvae. Tyler's model, going back to that agent-based model, we're making assumptions about milkweed density in different habitat patches around the state. If they're exposed to herbicides, the functional number of stems may not be as high as if we assumed there was no herbicide exposure. Niranjana Krishnan, a PhD student, is taking a look at insecticide exposure and determining the risk of a variety of insecticides, both lethal and sublethal effects on the monarch larvae and the adults. One of the ways we can do all this research on monarchs is in part through partnership with USDA ARS on site at Iowa State. And we have a monarch colony there separated. We have a 14 colony, a 15, 16, and now a 17 colony being started. So we can use the eggs and the larvae and the adults that come off the colony to do our experiments. So right now we're producing about 500 eggs per week, and about 300 of those are going into some of the studies I'm describing. The other 200 sort of cycle back into keeping the colony going. So we can look at any different age stage, and we've got all the techniques to track the larvae. This is an example of the representative insecticides that we're looking at now. We're looking at 3 neonicotinoid insecticides, imidacloprid, clothianidin, and thiamethoxam. Those 3 combined are the most commonly used in seed treatments in corn and soybean. You can see thiamethoxam and imidacloprid can also be used foliarly, so aerial or ground application. We're looking at beta-cyfluthrin as a representative pyrethroid. Again, that's only foliar application. And in the bold, you can see the Lepidoptera pest that these compounds are registered for. Using chlorpyrifos as a model organophosphate. And then chlorantraniliprole, which is an anthracyclic diamide. That's a new class of insecticides that are just entering the marketplace, and they'll probably start competing with the neonicotinoids and some of the other compounds on that chart. So what Niranjana is doing, and is just about completed, is all the topical exposures, so the insecticide that lands on the larvae. And she's taking a look at dose-response relationships for first, third, and fifth instars. As I said, that data is just about completed, and she's now undertaking dietary exposures to take a look at the potential effects of the systemics. We can then use spray drift models from EPA. In this case, we've been using egg drift, and we can estimate what the exposure is at different distances downwind of the field. And then using these dose response curves, we can estimate risk at the patch level. Exposure estimates for the systemic uptake's a bit more challenging. There isn't a lot of data on how much the milkweed are picking up downslope. But there's some work that was done in 2015 that gives some insights. It may be low part per billion in the milkweed. We just finished a study in Iowa, taking a look at some habitat plots that are in cornfields and soybean fields. Treated seeds stopped a few years ago. At this point, we can't detect any in the plants, even though we can see it in the groundwater and in the soil. We have a study going on this year with 10 plots in corn and soybean fields that have been using treated seeds for the last 7 years. So we'll maybe get a little bit better information. So what are our next steps? So with the work that Bob Hartzler and Sydney are doing, and Niranjana and I doing, and others, we're generating the data to predict what the risk is at the patch scale at different distances downwind or downslope of a field. We can then take that information and put that into Tyler's model, the agent-based model, which we've amended or enhanced by putting a population projection model on the outputs of the egg density model. So we can take a look at how many adults would be recruited based on the egg densities we predict, and then we can weave in potential insecticide exposure and effects to understand what the risk is at the landscape level. So we can do some what-ifs. We can do a what-if. What if we don't plant any milkweed within 125 feet of a corn or soybean field in Iowa? How many monarchs will we produce? What if we plant up right up to the field edge and we make certain assumptions about pesticide use. Now, so a pest like the soybean aphid, it only happens economically once every 4 years, approximately. So are we better off not planting anything near soybean fields because once in every 4 years, some patches downwind may be exposed, or are we better off planting all 4 years and take advantage of the 3 years when there's no pest pressure in that field? So this is a temporal and spatial and socioeconomic issue that's got to get worked out. This model isn't going to have the answer, but it'll hopefully provide information that can help inform crop management practices and monarch conservation practices. Because we're going to grow both. We're going to grow corn, we're going to grow soybeans, and we're going to grow monarchs. Thanks.